Moving, rotating and scaling objects can be done using transformations. There are different types of transformations: affine transformations, array transformations, Euclidean and morph transformations. But we'll start simply with the Euclidean transformations, which are transformations which don't deform the object. I will go to the move transformation. And to move, we need some geometry and a vector to define the movement. So for the basic geometry, let's make a small tower example. We could use like a center box, a box that is centered on a certain point, the base plane, and then it has an x, a y, and a z size. Let's define the size with a parameter. The size x and y will be the same, but let's increase the range of let's give it a name. Let's call it size. We don't need too many of those. Let's say somewhere between 2 and 10 units. Okay. So now we can define the size of our box, and we'll use another slider to define the thickness of our box. Let's call it the floor height. So it's a flat box, and we can independently set the size and the thickness. Okay. Now, if we connect this box to a movement, you don't see much happening because the initial vector, of course, is a 0 vector. So we need a vector for that, and let's go back to our unit z vector and connect it to the move operation. So we see the box and we see the moved box, and we can add a slider again to define the size of the movement. Okay, let's increase range a bit. For instance, if that's a floor story height, let's say it should be not less than 2.5 meters, maybe up to 4 meters. Okay, so now we can define story height, the thickness of the floor, and the size of the tower. And if we want to define multiple of these elements, let's use a series again. Series, and a series of positions. Let's use that one. And the slider here is the number that gets added in every step, and the last parameter is then the amount of floors, back to an integer, somewhere between 5 and 0. So 0 is maybe not a good ID. Let's start at least 1. So with 1, we get a simple translation that does nothing, but we can increase it. And there we see we have the small tower. One important thing to consider when using transformations is that Grasshopper creates new items when you transform one. So the box itself is one object, and the movements creates, in this case, 4 different objects. But the first one sits on exactly the same place as the original box. What you could do is disable the preview of this component. So it is used in the calculations, but the geometry is not displayed in the Grasshopper window. So now this box is only used for calculations, so we only end up with the moved ones. And the same goes for rotations and other transformations. So you can always disable the preview. They can also disable a component, but then you make a disconnection in the network, so the input is lost. So that is not what you want to do here.